Hey Year 12, today what we're looking at is definite integrals. So we're using the notation of the definite integral of the integral of a to b of fx dx for the area under the curve y equals fx from x equals a to x equals b if fx is greater than or equal to 0. So we can link the area under a curve to calculus, and we have that the fundamental theorem of calculus is the area enclosed by the curve y equals fx, the x-axis, and the lines x equals a and x equals b is given by the integral of a to b of fx dx equals the capital F of b minus capital F of a, where the capital F of x is the antiderivative of the function fx. And this is where we calculate our antiderivative of x to the power n is 1 over n plus 1, x to the power of n plus 1 plus c. However, we are going to let c equal 0 here. So we are ignoring this c and just using 1 over n plus 1, x to the power of n plus 1. For our first example, we're being asked to evaluate the integral of 4 to 5 of 2x plus 1 dx. What we want to do is we want to find the antiderivative of 2x plus 1. So the antiderivative of 2x is x squared, and the antiderivative of 1 is x. What we then want to do is a square bracket and put our boundaries from our integral of 5 and 4. What we then want to do is we want to substitute in 5 minus when we substitute in 4 into our antiderivative function. So this will equal 5 squared minus 5, take away, and then we want to substitute our second value inside brackets because this minus 4 will impact, or this minus will impact, so we'll have 4 squared minus 4. We can then work each section out. So 5 squared, it's pluses here. So 5 squared plus 5 is 30 minus our 4 squared plus 4 is 20. So we have 30 minus 20, which equals 10. So that means the area under the curve 2x plus 1 between x equals 4 and x equals 5 is worth 10. For our second example, we want to find the integral from 1 to 2 of x to the power of 4 minus 2 dx. So the antiderivative of x to the power of 4 is 1, how we calculate the antiderivative is 1 over n plus 1, x to the power of n plus 1. So it's 1 over our n is 4, so 1 over 4 plus 1, x to the power of 4 plus 1, minus the antiderivative of 2 is 2x, and then we put our square bracket and our boundaries either side. We then can simplify this a little bit. So 1 over 4 plus 1 is a fifth, x to the power of 5 minus 2x. We need our boundaries of 2 to 1. And so then we'll need to substitute in our 2 first. So we have a fifth, 2 to the power of 5 minus 2 to the power of 2 lots of 2 minus, in brackets, we now want to substitute in our 1. So we have a fifth, 1 to the power of 5 minus 2 lots of 1. When we calculate this, we have a fifth times 2 to the power of 5 is 32 over 5. Minus 2 lots of 2 is 4. Take away, in brackets, a fifth times 1 to the power of 5 is just a fifth. Minus 2 lots of 1 is 2. And when we put this all into our calculator, we get that the answer is 21 over 5. For example C, we have the integral of 1 to 2 of 2x minus 3 all over x cubed dx. What we want to do here is we want to split up our fraction. So we're going to copy this out as the integral of 2 to 1 of 2x over x cubed minus 3 over x cubed dx. So what we can do now is we can simplify these fractions by cancelling out the x's. So 2x over x cubed will turn into 2 over x squared. And then we'll have minus 3 over x cubed dx. What we then want to do is we're going to write this with some negative indices. So we'll have the integral of 1 to 2 of 2x to the power of negative 2 minus 3x to the power of negative 3 dx. And now we can find the antiderivative. So the antiderivative of 2x to the power of negative 2 is 1 over our n, which is negative 2, plus 1 times 2x to the power of negative 2 plus 1 minus, we then have 1 over our n of negative 3 plus 1 times 3 lots of x to the power of our n of negative 3 plus 1. And we need to do our square bracket at the end to substitute in our values in a moment, 1 and 2. We're then going to tidy this up a little bit. So when we tidy this up, we have 1 over negative 1 times 2 lots of x to the power of negative 1 minus 1 over negative 2 times 3 lots of x to the power of negative 2. And then we want to write what values we're going to substitute in at the end. Again, we can tidy this up, so it will be 2x to the power of negative 1 all over negative 1, so that we can just bring our negative out the front there, plus, it will turn into a plus because we'll have our minuses here marry up and make a plus. We'll have our 3x to the power of negative 2 all over 2. We can further tidy this up by making our getting rid of our negative indices. So we'll have negative 2x to the power of negative 1 is just negative 2 over x plus 3x to the power of negative 2 is 3 over 2x squared, and we're going to substitute in our 1 and 2 next. So we substitute in our larger number, our b number of 2 first, so we'll have minus 2 over 2 plus 3 over 2 lots of 2 squared. Then we're going to take away, in brackets, our negative 2 over our lower number of 1 plus 3 over 2 lots of 1 squared. When we put this into our calculators, we get, I need to put this into my calculator. Hang on. I don't have a calculator on me. Give me 2 seconds. Sorry. Well, we'll have minus 1 plus 3 over 8 minus negative 2 plus 3 over 2. Oh, God. What does that equal? Sorry, give me 2 seconds, peoples. So this is equal to negative 1 over 8. Perfect. Okay, for our next example, we have the integral of 8 to 27, of the cubed root of x dx. So what we need to do is we need to rewrite this, but with our cubed root of x as a fractional indice, which is x to the power of a third with respect to x. That's what our dx stands for. We then need to find the derivative of this. So the derivative is going to be 1 over our n of a third plus 1, x to the power of our n of a third plus 1. And we're going to substitute in our 27 and our 8 very shortly. Then what we need to do is we'll have 1 over 4 over 3, x to the power of 4 over 3, substitute in our 27 over 8. Now, when we have 1 over 4 over 3, what this is equivalent to or equal to is 3 over 4. So what happens here is our denominator of 3 comes up and is our numerator of our single fraction. So we will have this equal to 3x to the power of 4 over 3 over 4 and we're going to substitute in our 27 and our 8. We could change our fractional indices to be a third, or we can just leave it like so. So then we'll have 3 lots of 27 to the power of 4 over 3 all over 4 minus in brackets 3 lots of 8 to the power of 4 over 3 all over 4. In our calculator, we get that 3 lots of 27 to the power of 4 over 3 all over 4 is 234 over 4 minus 3 lots of 8 to the power of 4 over 3 all over 4 is negative 12. So we get our answer to be 93 over 2. Okay, our last example here is when we have the velocity of a particle is given by v equals 12t cubed minus 6t squared plus 8t plus 3 centimeters per second. We want to find the change in displacement in the first 3 seconds. Now we need to remember that our relationship between displacement and velocity is that velocity is our derivative of our displacement of x. So we have the equation v equals 12t cubed minus 6t squared plus 8t plus 3, which is equivalent to dx on dt, because it's the derivative of displacement of x, is 12t cubed minus 6t squared plus 8t plus 3. So that means that x is equal to the integral. Now we're talking about the first 3 seconds. So the first 3 seconds means we let t equal 0 to t equals 3. So they are our bounds, 0 to 3, of our 12t cubed minus 6t squared plus 8t plus 3 with respect to t, so dt. So now we need to integrate this. So the antiderivative of 12t cubed is a quarter times 12t to the power of 4 minus a third times 6t to the power of 3 plus a half times 8t squared plus 3t. We need our square brackets to show that we are going to be substituting in our values. Tidy this up a little bit and we get 3t to the power of 4 minus 2t to the power of 3 plus 4t squared plus 3t. 3 and 0 substituting in, and so now we must substitute in our 3 and our 0. So this will equal 3 lots of 3 to the power of 4 minus 2 lots of 3 cubed plus 4 lots of 3 squared plus 3 lots of 3 minus, now we must show our substitution of 0. Even if we know already that this bracket is going to equal 0, you must, and I am saying must, show this, okay? If you leave this out, you will lose marks. I can guarantee you must show this to show your understanding. Then we can just work out what this all is. So we will have 3 times 3 to the power of 4 is 243, minus 2 times 3 to the power of 3 is 54, plus 4 times 3 squared is 36, plus 4 times 3 is 9, minus now 3 times 0 to the power of 4 minus 2 times 0 to the power of 3 plus 4 times 0 squared plus 3 times 0 is 0. And again, you must show that it's 0. And so when we go 243 minus 54 plus 36 plus 9, what we get is we get 234 as our final answer. What you guys are doing is you are going to now have a go at exercise 703, question 1 to 3 ACE, and all of question 4.